So welcome everyone to my Julia tutorial. I'm just gonna share my screen. So it's an introductory tutorial to plot in Julia. So when you plot in Julia, it can be very powerful. We can do a lot of things that's very nice. For example, we can do something like this, which is a GIF. In this case, it's a Lorentz attractor. So we can do interactive or dynamic plots in Julia, like this or this one. But we're not gonna cover that today because it's more advanced. But the documentation to know how to do that kind of plots are here in this website that I'm gonna share to you later on. And it's very well written. There's a lot of examples. We have the installation first here at the left, and the manual. That's very important. So we have the input data. It's very well documented, and what's most important, I think, it's the attributes. So what we can, the attributes we can specify in our plots to make them prettier. It's really well specified here. And there's a lot of examples and a lot of people online that can help you do your plots. So today I'm going to show you how to do this plot. So it's 3 panels. The first one is a scalar plot. The second one is a density plot. And then the third one is a binomial plot with a box plot on top of it. So I'm going to start with the first one. And to do this, I'm going to need 3 packages: CSV, data frames, and plots. And I'm going to use the seeds data set that I've used in my neural network workshop before the pandemic. So yeah, I'm going to start by creating a temporary file name to download the data. So I'm going to use the function CSV to download the data. And the data is seeds, so we will have 8 variables. Just going to show it to you here, and just going to rename them very quickly. So we're going to have 8 variables. The first one is area, so it's the area of the kernel of the wheat. We have the perimeter, the compactness, the kernel length, kernel width, a coefficient of asymmetry, the kernel groove, which is in French, it's the I've written here, it's the rainure of the grain, and we have a type of cultivar that I'm going to use in my plot. So when we want to do basic plots in Julia, we can use the function scatter to do a scalar plot. So here we'll have, I'm just going to do it. Here we have the x values, and here we have the y values. So that's very simple to do a basic plot. It's just going to take, it always takes a while we do it first time. So Julia can compile the package correctly. But after that, it's going to be way quicker. So this is a basic scalar plot. We have in x the kernel length, and in y the kernel groove. And I'm gonna show you how to make that pretty and to add some features in that plot. I'm gonna use a specified color palette. We don't need to use that, but I like to do that because it allows me to have a specific color. So I just use the function RGB. And these are the values that I chose that we can look at on the internet to choose them that you want, but you don't need to do that because there's other ways to specify colors in plots. So my entire code to produce this figure here is everything that follows. So that's what's just an example to show you a basic plot. But to do the first panel, it's everything here. So I'm going to add one attribute one by one to show you how I can change this plot to make it a bit prettier. So I'm going to start by changing the color of the points. With the attribute color. So when we do that, we just specify the color equals, and we need the 2 points and the name of the color. If I wanted to use the palette that I've created earlier, here, I'm going to need to just specify the name of my palette. I can also change the transparency of my points with the attribute alpha, like this. Here I chose 0.8, but it can be anything. It can change to 0.6, for example, to make it a bit more transparent. And when you create plus in Julia, you always have a default legend. Here is a Y1. And we want to either get rid of that or change the name of the label. So to do that, I'm just going to remove it for now. I'm going to change it later. We just specify label equals and 2 brackets and something empty. So it gets rid of it. And when I do plots, I like to make it in a box. See here, it's in a box. So I think it's like cleaner and a bit more pretty. And I can specify a DPI, which I don't know exactly how it works, but it allows my plot to be in a better quality at the end. I'm gonna fit a linear regression with it, just with the function smooth, which fits a normal linear regression. Like this, and we see the line, but I'm gonna change the appearance of my line with line color. And here I'm gonna use the palette, one of the palette I specified here, because it's pink and I think it's nice. And I'm gonna change also the line width of my of this regression line, like this, to make it more apparent. And finally, if you want to change specific axis or add anything to the plot, you can write something on the plot with this exclamation mark. So if I did in other scalar plot, I will write scalar with the exclamation mark, which will add another scalar plot on my actual plot. So if I want to change the x-axis, I can do that. I can write x-axis with the exclamation mark. And here I have the x label that I'm going to name kernel length in centimeters, and my x limits, which I don't need to change it, but just to show you how I can do it, I will change it from 4.8. So the minimum x will be 4.8, and the maximum will be 6.8. And that takes a little while to do, because it's the first time we do it, but after it's more quicker. And I can do the same thing for the y-axis. Like this, so the y label here, y-axis with the exclamation mark, so it adds onto the plot, and the y limit here. So it's gonna change the limits on my plot, and add the label for it. It's just gonna take a while, yeah. And if I wanted to change the dimension of my of one of the axes, let's say I want to put the x-axis in log, I'm just gonna do that like this. So the 2 points plus log, and that takes also a little while to start. Oh, I have a question here. Yeah, you can ask a question, Valentin. Make doesn't work. If you push a second scalar plot on top of the first one, does the limit of the axis update on their own? If you put a second scalar plot on the plot, the axis will be the axis of the original plot, except if you specify it in your second plot. If you specify two axes that are different, I'm not sure what it's going to do, but we could experiment it and see what it does. Yeah. Here in my final plot, I'm not going to put it in log. I just wanted to show you how it was possible to do it. Okay. In my plot here, I added a line in pointier. I don't know what it is in English. And this line is the 1-for-1 line. So I'm just going to add it with while adding another plot. So what I'm going to do to do that, I'm going to use this code here. So I'm going to specify a x values, can be anything, from the minimum kernel length. So it will be the x values of this point here, to the maximum kernel length, which will be the value of this point here. And it will go by 0.1. So I'm going to add a vector of some values that I'm going to plot here. So I'm going to have this line here with x. So it's this values plus this values again. So it will be 1.1 line. I'm going to change its labels with label 1.1. I'm just going to show you what it does right away. Okay, so it does something like this. Because I already did it once, it gave 2 legend because it did twice, so I don't want to do that. And I can change the line style of the of my line by writing line style. You got dot. You can change the line color like I did before. I can change the line width with this function. I'm gonna put it to 1. And I can change also the position of the legend just by specifying legend equals, let's say, right. I could specify top right, top left, or a lot of other things. And I would also want to change the color of the legend, so it doesn't have so it's not in a box. So I think it's a bit more pretty. So it does something like this, where we have the legend here at the right, 1-to-1. And this was the first plot in my panel. And I'm going to move on to the second plot if I don't have any questions. Is everything okay so far? Yeah, okay. Okay, I just gonna move your faces if you don't mind. Okay. So the second plot will be a density plot. And each color will represent a different cultivar because we have 3 cultivars in our data set. In the solid lines, it will be the density of the kernel length, and the dot lines will be the density of the groove length. In Julia, when you want to do a density plot, you could use the package statsplot. You don't have to, but I'm going to use it for now because I like to use it. Just going to take some time before it compiles. And this is the entire code, but I'm going to go like I did before, shrunk by shrunk, to show you how to do a density plot. So just with the function density. And here we have the x-axis. And here we have the groups that we want to specify. It always takes a while to start, but it's always quicker after. here we go. So this is an easy to do first density plot. So we have our three groups, and we have the three colors by default and the legend by default that we will want to change. So we are start by changing the line width of every density curves, and I'm going to change the X labels. Before I showed you that I could change the X labels by adding another component in the plot, but we can also add it directly in the first chunk of code by this X label, and I'm gonna name it kernel or group length. And I'm going to also change the Y label to density. I'm going to do it like before. I'm going to change the X limits to 4 and 7.5. And I'm going to change the label of my legend. So when we have a legend with three components like this, we don't put any comma or any semicolon, column between the elements. We just specify it with three different characters or three different names, but without anything between them. So I'm going to name the first one C1, the second one C2, and the third one C3, because it's a cultivar 1, cultivar 2, and cultivar 3. I'm also going to change the color of the line. And it's the same principle as the label. We don't put anything between them. So here it's pal point C1, because I'm going to use my palette here. That if I show you so my palette here is an array of four components. So if I do pal point C1, I'm just going to give me this thing here. So I'm going to specify the palette or the color of the three lines, pal point C1, nothing between them, pal point C2, nothing between them, and pal point C3. And I just shows those colors because they are colorblind friendly. But you can do whatever you want with this palette, which is very nice. I'm going to change this. I'm going to change the position of the legend, top right. It was already top right. I'm going to also change the foreground color of the legend by nothing. You see the box isn't good. And I'm going to do like I did before. I'm going to put added frame and change the quality of the plot with frame equals box and DPI equals 120. So that was it for the first part of my plot here. But I'm going to add the dotted densities just now. So I'm going to do like what I did before. I'm going to use this function here. So again, density, but with the exclamation mark, because I want to add it on the plot that I already have. Just going to put it here. So it's really the same thing, but here we're going to add the kernel groove instead of the kernel length. We're going to have the same groups seed cultivar. We're going to have the same line width, but we're going to change the line style to that. And we are going to have the same color palette for the three groups. And we're not going to add a legend, because if we added a legend, we will have twice the same legend. And that's it. That's it for the second panel. Any questions?
Yeah, if you want to save the plots in PDF, is there a way to do that?
Yeah, I'm gonna show it after. I'm gonna merge the plots and save it after. Yeah. Okay, so now I'm gonna show you what to do the final plot, which is a variant plot with a box plot with a dot plot, all in one plot. Okay. I'm just gonna start by converting the seeds point cultivars, which are numeric in my which are the floats 64 in my original data set. I'm gonna convert them in string because it's easier. It will be easier to have those categories here at the end. So here we have the first part here. It's convert to integer 64, and I'm just gonna to get rid of the 0.0 here. And after I'm just gonna use the function string to put them in string like this. Okay. So when you want to do a variant plot, again, the basic is very easy. Just the function variant with here the group cultivar integer, and here the thing we want to plot. So the kernel length in this case. So this is the basic variant plot. And I'm going to change, like I did, the color of every group. I'm going to use the same color as I used for the density plot. So pal.c1, pal.c2, and pal.c3 with this time comma in between. I'm not sure. Yeah, this is something I didn't understand yet. But in this case, we need to put comma in between. But you just need, I think you just need to experiment what works, and if it works. Yeah, because I didn't understand yet, but I'm sure there's a good reason for it. I'm gonna remove the label, and I'm gonna change the X label and the Y label, and add the frame and DPI like I did before. Here we go. And now I'm gonna want to add a box plot on top of it. So again, I'm gonna use the exclamation mark with my function box plot to put it in front of it. So we again will have the cultivar integer. So the same thing from same thing that I use for the variant plot, and the seeds kernel. My box plots will have a color of a gray color, and I'm gonna add the transparency of 0.5, and again no label. That's it. And I'm gonna finally add a dot plot on top of it just to show maybe to show more a bit the distribution of the different kernel length for each cultivar. So again, it's the same thing as the box plot and the variant plot. The group here, the kernel length here. The color of my points will be gray with an alpha of 0.5. You can change the marker size with this attribute, and I'm gonna have no label. There you go. And that was it for the third panel. So what I want to do now is to combine those three figures together in this fashion, in this arrangement. And I'm gonna also add the little subscript here in my figures, in my figure. So I can specify a specific layout using this macro here. So my layout will be L. I'm gonna name it L. I use this macro layout, and here I can specify what my layout will be. So here I want in my first row 1 plot, and in my second row 2 plots, like this. My first row 1, and my second row 2 different plots. And here in the here it's just specifying the relative size of each plot. So here I want in my first row the plot to be 60% of the entire figure. So here it means that the author will be 60% of the entire plot for my first one here. So when I want to add plots together, I just do the function plot with the name of my 3 plots, plot A, plot B, and plot C. I specify my layout. Layout equals L. The layout I just specified before. I can say that there will be no legend. So this is what it does. Yeah, this is what it does. Plot. Whoops. I just forgot to specify the plot A. I just didn't name it, so I'm gonna name it right now. Okay. Just gonna take a while before it finishes everything. Okay. So here, okay, I need to specify the layout again. Okay. So here we have the plot with the three different panels, and I'm just gonna add the title of each plot using this, only this. So for each plot, I will have those titles. For the first plot, it will be 1, 2, 2, and 3. You can specify the title location of each plot with this function, and the title font. So the size of the title. Whoops. I forgot the parentheses.
It's the square brackets.
Ah, I forgot that. The square brackets?
Yeah.
Oh, yeah, you're right.
Thank you. Yeah. And then you have to erase the last one. After font 8, you have another one.
Oh, but thank you. I didn't put it as the good place. Okay, there you go. We have the different subscripts here. 1, 2, 3. And I can save my figure with save figure. It's going to save it in PNG, but I can also save it in PDF as well. And I'm going to specify the path, join path. And this is the path. So it's the same thing as if I wrote tutorials dash Julia tutorial using the function join path. And my figure will be named fig.png. And that's it. I can go here and find my fig.png in my tutorials and Julia tutorial. Yeah. So yeah, so that was it for the introductory workshop. But yeah, like I said before, we can do a lot of things with Julia, which are very nice. Like in my project, I already did a GIF, a bit like we saw in the home. And it's really not, it's really straightforward to do it with Julia. And every steps to do that kind of really nice plot are really well explained. You just have to follow the example and put your data instead. And yeah, that's it. Do you have any questions?
So the format of the graphic that is saved, it depends on the file name, right? So here you use PNG.
Yeah.
If you wanted to save as a PDF, you would simply put PDF. And
yeah, I'm not sure if it will work. I think it will work. I'm not sure. I can try.
I'm asking because very often I like to produce a vectorial graphic that I can then edit in Illustrator.
Yeah. Yeah, I think it worked. Yeah, it worked. We have it. We have here.
Cool.
Yeah. Do your project events well?
Yeah, definitely.
Okay.
The other thing is when you created your layout, you first had to create each of the plot individually. Is there any way to create those plots without actually drawing them?
You mean altogether without like?
So
you mean altogether one shot?
No. So the first time you create the, let me just. So the first time you create plot A, for example, it does create that graphic in the in the plot frame.
Yeah.
Is there any way that it doesn't produce that graphic at that time?
Yeah, I'm sure there is. I'm not sure how I will do it, but I'm sure there's a way. Yeah.
Maybe
yeah, if I may, for instance, I think in this call, instead of just calling like plot A, you could just use the plot parenthesis and whatever the thing that generates that plot at that time. So like in the combining plot call, you can just call the first one formula for the first plot, and it's gonna do it this way. So you don't have to do it like before. You could just do it like at that time. Exactly. It's just more convenient often if you're going to combine a lot of them to yeah, to like predefine them, so it's easier to see. But you could just put that in the combining plot call.
Yeah, I was more thinking of a situation where the different panels are created, for example, through a for loop, and you want to prototype just one, and then after that, when you want to generate the 16 graphic that will be combined, you don't want to see them flashing on the right side.
Oh, okay. Well, you can do plots in a for loop, so that works fine. What you can do is create an empty array, an array of like type any, and you can just push the plots to that array. So like in your for loop, they're not like popping up all the time. They're just stored in that array, and then you can display any element in that array like one at a time, or just save it, or yeah.
Yeah. Any other question?
If maybe we can use also the dot command after the function, and then it won't pop up, right?
Yeah. If you put a semicolon after a plotting call, it's not gonna display.
Yeah. I'm gonna share the code for you on Slack if you want. So I did the resource, so the website that I showed you, and I did also the link to the information of 3 other packages that are very useful when you plot in Julia. The most common are maybe Gadfly, PyPlot, and the one I use today, StatsPlot. So I am just add the link here if you want to go further.
And they do all go into the same plotting ecosystem? They are kind of add-ons, or they are a completely different way to make plots?
Gadfly, I think, is a like of it's resemble to ggplot. If I'm not mistaken.
Yeah, I think it's the grammar of graphics thing. It's more inspired by that. So like these are backends, they're called. So it's like kind of a different way to generate the plots, and with like some different arguments. PyPlot for some things is similar to JR, which is the default one that Francis used at that time, but not for all 4 functions. So you may have like different arguments that work only for PyPlot and not for JR, and the other way around. So depending on what you want to do and what functions you need to use, you may prefer one backend to the other, or whatever.
Yeah, exactly.
Cool.
Okay. But thank you for coming.
Thanks.
Thank you, Francis.
Thanks, Francis.
Merci.
Okay. Have a good day. And good luck with your project.
Bye.
Goodbye.
Bye-bye.
Okay, save it. Nice.